so it doesn't distract us. Okay, so first stage, I need to see what the heck this looks like. If you're rotating about the y-axis, which we are, then does it not mean we need everything in terms of y? Right. So that means I got to figure out what these two guys look like, and then the region between them is going to get rotated about the y-axis. So I guess you could go in and you could use GeoBra and sketch the things. I believe if you do the y squared equals 2x, it looks like that. And if you do the other fella, x equals 2y, it looks something like this. So the piece that we are going to be rotating, at least in my sketch, is a very skinny banana. So far, so good. Right, now I need to know where here is, which is pretty obviously 0, and I also need to know where he is. Well, I'm trying to solve when this is equal to that, but they're not really written in a format that makes it obvious. So I'm going to rearrange some of the information to make it more consistent. So I'm going to take this guy and divide them by 2. That way, both of them are x equals. That way I can match these two together. And that tells me that they're going to intersect when that's true, which if you double everything is that, and if you subtract 4y and then pull out y as a common factor, we get the two solutions. Y equals 0 I knew about, and y equals 4 I was hoping to find. So I now know that number. So what we have here is our basic setup. I know what the shape looks like. I know it's been rotated about the y-axis. So I now need to set up my little typical rectangle, which if you are doing this, your rectangle is going to go that way at right angles to the axis of rotation. And we need to figure out essentially pi big take away pi small. So let me set that up. So it's going to be the volume from y equals 0 to 4 of pi, the big radius squared, take away the small radius squared, and dy in this case. And I know it's dy because it's being rotated about an axis parallel. In this case, it is the y-axis. But also, if it was parallel to the y-axis, everything would be in y's. So the last piece of the puzzle is to find out what this guy is and what this guy is. Right, my picture's very tiny, but that's just the way the thing worked. The distance from the axis of rotation to here is the little radius, and the distance from axis of rotation to here is the big radius. So basically, I just need to figure out in terms of y what that distance here is and what that distance here is, which is exactly what these two things are. Because x equals, because that's essentially the x coordinate of that point, and the other one is an x coordinate. And the furthest away one is this one. And the closest is this one. So what you now have is pi, the integral from 0 to 4, 4y squared, take away 1/4 y to the 4, dy. And at this point, it's really just a matter of power rule and plugging in 0 and then plugging in 4.
Okay, I was just kind of confused on the like finding the radiuses.
It's always going to be awkward. It's a very visual thing. The radius is the distance from the axis that you're rotating to either the top or the bottom of the rectangle. And the rectangle I'm talking about is this tiny little horizontal guy in this case. Now, when you switch the axis of rotation, your line becomes a vertical rectangle. And so from, say, the x-axis to the bottom and the x-axis to the top, they're going to be the big and small radius. And that is essentially that one.
Okay, thank you.
You're welcome. Is that the only one? I don't think we'll have time right now, but we can have time after this if there's some more that comes up.
Yeah, I had a couple other questions.
We can do that at the end then, because other people might want to join as well.
Okay.
How are you today, Emma?
I'm doing good.
Well, glad to hear it. Catherine, how are you doing? There you go. How are things, Catherine?
Oh, just enjoying a rainy day. How about you?
Living the dream.
Yeah, we even had thunder and lightning here this morning.
You did? Never heard it.
Yeah, my husband was telling me about it. I didn't hear it either, but he was telling me about it.
Well, it's been pretty miserable weather, so I guess thunder and lightning can't make it any worse.
I guess it could be worse. It could be snow and ice.
Oh, hey, don't even think that. We're just not going to have any of that. I've decided.
Yeah, driving in it.
Yeah, I've just decided that we are not going to have any kind of horrible weather.
Yeah.
I've figured out I'm in charge of the weather now, so it ain't going to happen. No, it's not. If I'm making you dizzy, I'm trying to figure out a way to get everything I want on the screen at the same time, and it's just not happening. Okay, I guess that'll do. Can everybody see from the edge to the edge and top to bottom?
Yep.
Okay, we're good. How are you doing, Rachel? Living the dream?
Sure.
Sure. Okay. Trenton, how's your coffee level? You awake today? He's that awake. Okay. Well, good morning, everyone. Hope you enjoyed your long lie in the morning. I did. And we are about to start 6.3. So we have 6.3, 4, and 5 to do. 6.3 is going to be a new method for finding volumes of revolution. The method that we finished last week is called, well, it's different names, but it's called either the washer or the disk method. It's the name we give to that one. And the one technique we're going to find out about today is called the shell, sometimes also called the cylindrical shell method. So if you want to do search online, shell method or cylindrical shell method. Now, if you read over the text and watch some of the videos that we've got, you'll actually see the proof of the formula, but we're on a kind of tight schedule, so I'm just going to say that it works. And let's try and explain it. Well, there are a couple of different nuances in this, so it makes it a little bit hard. So I've given you the most generic version of the formula that I can when you're rotating about the x-axis. So you imagine you've got this shape of a curve, and the curve, when you rotate about the x-axis in this method, the equation of that curve has to be written down as x equals y cubed, x equals 2y plus 1, which makes it's kind of backwards to what the other method was, right? You wanted to rotate about the x-axis, you wanted it to be written as y equals x cubed, but here you want it to be written as x equals whatever. So you have your function, x equals f of y, from here to here, going from c to dc. And the area that's going to be rotated is this shaded area going this way. And the formula for getting it is the integral from y equals c to d. So everything's going to be in terms of y. So c to d. 2 pi, a thing called the radius, multiplied by a thing called the height, dy. And the radius and the height are going to be numbers or expressions in terms of y. So there isn't an x in sight when you do this method. Even although you're going to be rotating about the x-axis, none of the terms that get used have x's in them, they're all y's. So how do we get the radius? You draw a rectangle, and here's another difference. Do you notice that this rectangle is parallel to the axis of rotation? On Friday, wouldn't the rectangle be vertical? So that's different. Everything's kind of back to front. So the methods are, you know, if this goes left, that goes right. If this goes up, that goes down. If this uses X, the other method uses Y. It's almost like a complete flip around for everything. And so you sometimes get mixed up because your brain is on the disk method, but the question is not. The question is in the shell method. And that process can really throw your brain if you're not careful. So we have this thing called the radius, which is basically the distance from this rectangle to the axis of rotation. I am going to stop for a second. And okay, go away, go away. If you hold on, I am having issues. There we go. I now have muted you all so we don't get whatever that sound was distracting me. We won't have that to worry about. Right, so hopefully it didn't distract you too much. Or at all even, right? So, from this rectangle to the axis of rotation is called the radius. And whatever that distance here is, we're calling that the height. And the reason that thing is, if you look at the picture of the proof, see that tiny little rectangle? It gets rotated about the x-axis and it makes what's called a cylindrical shell. It's basically like a tin can, right? The thin piece of metal that would make a tin can. And it's adding all those up that gets you the volume of the shape. So that's where this weird stuff comes from. So let's put that into practice. This is question 3 from the homework. We're being asked to take this curve from x equals 0 y equals 9, y equals 11, and we're asked to rotate about the x-axis. You really do need to sketch these things, so you should have kind of have GeoBra and speed dial, so it should always be handy to type things in. But in this particular case, we are going to sketch the graph. But in this particular case, I can get away with that. This does say xy equals 9, right? But if I rearrange it, it's x equals 9 over y. And I happen to know what that looks like. Actually, it just looks like 9 over x. So it basically looks like that shape. So that's what x equals 9 over y would look like. X equals 0. Which axis is x equals 0? The x or the y? You get a 50-50 chance of guessing. It's the y-axis, right? So we've got the y-axis. And then if I plug in y equals 9, can we pretend that y equals 9 is here? And y equals 11 is here. You see, basically what that has allowed us to do is to find out this information here. It's basically just telling us what region is going to be rotated, and we know it's going to be rotated about the x-axis. So that's step 1 done. Sketch the graph. Get a good look at what you're rotating. What does the shape look like? And I think we do. So the next stage is pick a random rectangle and find out what the radius and height are. Now, the radius is the distance from here to here. Now, that guy that I've just put in is at a height of y, right? So won't that radius be the distance from here to here? Agreed? Now, if that is y, won't the radius just be y in this case? The distance from the axis of rotation to that point is called the radius. Now, what's the height? Well, isn't the height the distance from here to here? And won't the distance from here to here get you x equals 9 over y? So there's my height. So the radius is from your rectangle to the axis of rotation, and your height is how long your rectangle is. Both of those things have to be in terms of y because of this. Step 3, get the answer. So the volume is the integral from c to d, 2 pi radius, height, dy. In this case, from 9 till 11, that's c to d. 2 pi, the radius is y, the height is 9 over y, dy. Don't really need brackets around them, but I'll put them anyway. That gives us the integral from 9 to 11. Oh, this will not happen very often, but here's something really unique. Do you see any simplification in this calculation?
And cross out the y's.
Do not expect every question to end up as nice as this one. But do you see you get 18 pi? Well, you want to finish that off? 18 pi gets you 18 pi y, from y equals 9 to y equals 11. Since I'm running short of room, 36 pi. So if you rotated this shape about the x-axis, the volume of that shape would be 36 pi. I wonder what that looks like, just out of curiosity. Oh, it looks like a screw with a hole drilled through the center of it. Imagine the entire shape. Yeah, just curious. Okay, any questions about that?
I do. If we're
Yes.
trying to find the radius, like in this example, it just says y,
Yes.
and other questions will be more than just y.
Yeah. When you rotate it about the x-axis, the radius is just going to be y, which makes life easy. But when you rotate it about a line, you know, like parallel to the x-axis, that would be a line like y equals 9 or y equals -2, then the radius will change. It will end up being y plus a number, y take away a number take away y. It'll still be y in it, but there'll probably be a number that will be added or subtracted with it. So that's what the difference will look like. We're going to see one, I think, shortly, that does exactly that, so you can see what it looks like. Any other? That was a good question. Any other questions? Okay. Put that one over here, I think. So the next one is like question 4. And this time we're going to take the curve y equals 2/3 x. It's going to be y equals 0. It's going to be x equals 0. And it's still going to be rotated about the x-axis. Now I know the shape's going to be rotated about the x-axis. I need to sketch this guy. At 0, it looks like this, so it's a pretty boring curve. Y equals 0 and x equals 0 are basically this x. Wait a minute. Can I check that? Glad I did. Y equals 0 and x equals 0. That guy. This is now much more sensible. So that's the region, this shaded region, that's going to be rotated about the x-axis. So what we need to do here is we need to take our little guy, that fella, and that tells me that he's at position Y. And can you see that the radius then is Y? And the height? Well, won't the height be the distance from here to here? Now, when you're looking at this curve, the distance from here to here is basically that distance, right? Which is the value of the curve, the function. Do you notice that this function is not written in the form that I need it to be written? Doesn't this answer here have to be in terms of y? but really I've got y equals something in x. So I'm going to have to do a little rearranging. So here's some algebra. If y is equal to 2/3 x to the power of 2/3, what is x equal to as a power of y? That's the algebra we need to be able to do.
Root 2 over y cube, or
Tell me the fraction rather than saying in terms of
Um,
roots.
the 3/2.
That's it. And you can check that, but it is. Well, that's step 2 done. Final step is where all the integration takes place. It's going to be the integral from 0 to 8, 2 pi, radius, height, dy. You combine these two together, and at this point I'm going to do my dot, dot, dot. You can pull out that 2 pi outside the integral. I definitely pull out the pi. But aren't you just going to do a power rule? Right, you're going to integrate y to the 5/2 by adding 1 and dividing by the new power. And that will be the finish to that question. Are we good? Matthew?
How do you know the radius is y?
The radius is going to be the distance from that rectangle to here. And you see this little rectangle I've drawn? He's always going to be drawn at position y. So I know that that number is y. So isn't that distance from 0 to y just y?
So you just call it y?
Well, I don't just call it y for random reasons. Isn't that location a random position on the y-axis? So calling it y makes sense.
Okay.
If I was doing a rectangle where this pen is, see that pen there? I would call that position x. If I'm doing it this way, I would call it position y. You're going to have to do some thinking on these guys, because that's just, unfortunately, that's just the way they are. Got another one set up here, eventually. This is like question 10. X equals y take away 2 squared. X equals 1. And we're now going to do it about the line y equals 1. That doesn't look right. You check. Okay, so I'm going to put this guy here into the calculator, not the calculator, into GeoBrush so I can draw it. And it's going to look like this guy here. Actually, I got a little sketch. It's going to look like this. Okay, so this is what x equals y take away 2 squared looks like. Now, if you put in x equals 1, which is about here, you get that shape. And we are going to be rotating it about the line y equals 1. And my diagram is really messy looking. I apologize for that. But this is the axis of rotation. Do you see that it isn't the x-axis, it's just parallel to the x-axis? So far, so good. That's what this looks like if you put it in GeoBra. See if we can move on to step 2 then. Right. The rectangle. Put them anywhere you like. Let's put them here. And this rectangle is at position Y. So far, so good. Now, the distance from here to the axis of rotation is called the radius. So let's figure out who the radius is. If you took this rectangle all the way to the x-axis, wouldn't that distance be y? We're going to only take it from this rectangle to that dotted line. So what is the radius? What distance is it?
It would be like y plus 1.
Is it plus or take away? Is it bigger or smaller?
Minus.
It's a minus. So that's one of those plus minus situations. When you do the radius part, this guy here, he's always going to have, in this case, a letter y. He's always going to be y plus a number, y take away a number take away y. That kind of look to it. There won't ever be y squareds or y cubes or weird y's. Just a y, because that distance is basically that position to the axis of rotation. Now, the height. This is new. Do you see this rectangle has a start value and a finish value, right? It doesn't go all the way to the end. This start value is 1, and this finish value is that. So if I want to know the distance from there to there, which we call the height, it's going to be big number, take away that guy. So from here, it's 1, and from here is whatever that function is called. It's essentially 1 take away x, but replacing the x with an expression in terms of y. So that makes the height 1, take away y squared, take away 4y, which means you add y, take away 4. So I end up with, I don't know, 4y, take away y squared, take away 3. So I have a radius of this guy, and I have a height of this guy. So that's step 2 done. The final step is putting all the pieces together. So the volume is going to be there's a number I have not found, which I just realized I'm going to need. Doesn't the y value start at 1 and it finishes whatever this guy up here is? Then it's going to be 2 pi radius height I need to know the y coordinate of this point, because that's, you know, the y's go from 1 to whatever this mysterious number is. So how do I find out what that is?
Intersect.
Okay, now the intersect that we have to deal with, so I'll do this at the side, is the vertical line x equals 1 meeting up with the curve y minus 2 squared. So if you set them equal to each other, and then you have to spend some time doing the usual math stuff. Now, if you're really lucky, when you do this in GeoBra, won't these two places be kind of readable off the diagram? You just look at it and say, oh yeah, that guy's at 3 and that guy's at 1, and you're good to go. That's how we would find out what that guy is. So we've got from 1 to 3, 2 pi, the radius, height, dy. And then you put in the numbers, and let's see what we get. 2 pi, y take away 1, 4y take away y squared take away 3 dy. Let's pull out that 2 pi. Okay, how on earth are we going to integrate this?
Distribute first.
Yeah, it's just going to be one ugly version of FOIL. Now, normally when you do FOIL, there's 2 and 2, but you can do it when there's 2 and 3. And basically, you take the first guy and you multiply it with these 3. Then you take the second guy and you multiply it with these 3. Can you imagine some big, ugly polynomial and then you use the power rule? Any questions about that one? Are we good? Okay. There's going to be a lot of thinking during this homework, isn't there? That guy, this fella, and it's going to be rotated about the line y equals 2. So 5y squared, what does that look like? It looks something like that. Oops, that's the origin, right? Y greater than or equal to 0 means everything above here. X equals 5 is about here. This is the region. So I'm not right about this question. Let's see, right. Oh, darn it. Yeah. I couldn't figure out where I was going to put the line y equals 2 because I guess my scale looked so big that I thought I was going to cut through the middle of the shape, but actually I'm not. I was going to go there. So, if you find this fella here, can you trust me this guy is 1? So when x is 5, y is 1. Okay, here's our go-to rectangle. Here's our axis of rotation. This guy here is y. The radius is going to be that distance. This From here to here is 2. From here to here is y. What's the radius? Two to there. What's that distance in
Minus
terms?
2 take away 1.
2 take away 1. On the other hand, isn't the height just 5 take away this guy? 5 take away the curve. 5 is big, curve is slightly to the left, so that's why it's this way. We're done. Step 3. The volume is the integral from y equals 0 to 1, 2 pi, the radius times the height, dy. Pull out the 2 pi. The radius is this guy, and the height is that guy. Once you can set this up, the hard part is over. After this, it's just a matter of integrating whatever you get. Pretty good chance it's going to be a polynomial. And can you see I'm going to have to FOIL this out and do the power rule? Are we good?
Professor,
Yes.
how do you know like when to use which formula?
Dead easy. This formula here with the dy on it, you always use it when you're rotating about the x-axis or anything that's parallel to the x-axis. So if they say rotate about the x-axis, rotate about the line y equals 2, the line y equals -4, the line y equals 7, anything that looks like this, you're going to use this formula. That means the one that uses y's, the dy formula.
Okay, thanks.
Are we good? Then you should be saying, and your question kind of led up to that. So how do you do it when you're rotating the other way? Well, here we go. Guess I should call that number 2. Rotating about a vertical axis. So how do you find the volume of a shape when you rotate it about the y-axis or any vertical axis for that matter? Well, the great news, to me that's great news, isn't that formula pretty much identical to the one we used a minute ago? Let's see what the differences are. Well, when you rotate about the y-axis, do you notice that everything's in terms of x? When you rotate about the x-axis, everything's in terms of y. When you rotate about the y-axis, everything's in terms of x. Apart from that, isn't the formula identical? 2 pi, a thing called the radius, a thing called the height. So can you imagine I have a shape, y equals f of x, a curve, from x equals a to x equals b. Your rectangle, I guess I should be consistent because I tend to make my rectangles green, right? Our green rectangle will now be at position x, well, because it reaches the x-axis, right? So it's at x. The radius is the distance from the rectangle to the axis of rotation, and the height is how long the rectangle is. So a lot of the stuff that we've been doing is pretty much the same sort of a stuff when you rotate it the other way. So if you rotate now about y-axis or anything parallel to the y-axis, this is going to be our go-to formula. Okay. So let's show you what it looks like. Question 6. Suppose we take y equals x cubed, y equals 8, x equals 0, and we rotate about x equals 7. So we're jumping right into the deep end here. Here's step 1. Y equals x cubed. Looks something like that. X equals 0 is the y-axis. Y equals 8 is a line that goes here. We are going to rotate this thing about a line called x equals 7. So that's what the picture looks like. Now, if I'm going to rotate this shape about this axis, which is vertical, I will make my little rectangle there. And I will call this guy here X. And I now need to get my pens all sorted out. Step 2, I now need to find out what the radius and the height are in this story. Now the radius is from here to the axis of rotation. The total distance from that dotted line to the y-axis is 7. The distance from here to here is x. So what's the radius going to be?
7 and take away x.
Okay. You agree? Now the height of that rectangle, isn't this guy 8? Isn't this guy y equals x cubed? Basically the height, unless it's a very simple shape, isn't it going to be the top guy take away the bottom guy using x's? And the top guy here is a number and the bottom guy is a curve using x's. And step 3, well, the volume is the integral well, we need to do a start and a finish. Well, I know the x value at the start is 0. Won't I need to know the final x value here, right? From 0 to that number. What is that x value here? That's the clue.
Where they intersect?
Yeah, and you know they intersect at 2? But you can check it, but they do. Isn't 2 cubed 8, so they intersect at 2? X equals 2. So 0 to 2. 2 pi radius height dx. It's going to be integral from 0 to 2, pull out the 2 pi. A radius followed by a height just going to FOIL this horrible mess out, see what we get. 56, that guy, and that guy. And then you've just got some horrendously big power rule to do. So try and think of how this is constructed. You visually need a picture. If you think you can just skip this line, you're sorely wrong. I don't see anybody who can honestly take this information and figure out that that's what the radius and height is without getting it wrong more times than they get it right. Then you've got this fella, radius and height, and then put it all together. It's done. Any questions?
I'm a little bit confused because last week we learned about all those other formulas. And like, how did those relate to these ones?
The disk one
Yeah.
doesn't. It's a totally unconnected method. There is no
But
connection.
I just don't understand. Like,
The only
how
thing they
this is-
do is they both find volumes, but they find them in totally different ways.
Oh, okay.
So don't
Does the
try and
one
figure out how the disk
inaccurate?
method and the shell method interact. They essentially don't. They have nothing in common. In fact, worse than having nothing in common, aren't they exact opposites? What do I mean by that? If you rotate something in the x-axis using the disk method, isn't everything in terms of x's? Go back and check. If you rotate something in the x-axis using the shell method, isn't everything in terms of y? So they're kind of mirror images of each other. What you do with one, you kind of do the exact opposite in the second. The formulas aren't even the same. Pi big radius squared, take away small radius squared. That's what a disk method general formula is. Here it's 2 pi radius height, so even that isn't the same. So no, I don't see any advantage in trying to make a connection when there isn't one. Just think of it as two totally different ways of doing the same question. So I guess you might say to yourself, why do I need two totally different methods? Why can't I just use one of them? And that way I don't need to go through all this pain of figuring out how to do two methods. Some shapes rotate well about the x-axis when you use the disk method, and they're really ugly when you try and use the shell method, and vice versa. So it's just a matter of some shapes, it's better to use one than the other, and that's why we need two. Well, I'm going to try this. I know it'll be a quick one, but I'm going to go for it. Y equals, it's a weird one, 11x take away x squared. Y equals 28. And it's going to be rotated about the line x equals 4. So, what does the line x equals 4 looks like? It looks like a line over here. What does 11 minus x squared look like? It looks something like, that doesn't look right. Let me check. I'm checking as we speak. Something's not. I know how you draw that. That's my problem. I just don't see how this makes sense. This axis is in the wrong place. So where the heck should it be? Okay. That's what this guy looks like. That I know. That's my problem. X equals 4's here. And you don't have axis rotation in the middle of shapes. You just don't. So I must have misread question 7, and we don't have enough time for me to fix that one. But This information does not work with that. Now, if this was -4, I'd be totally cool. I could do that. This shape here, y = 28, would be up here. So I could definitely do that shape, but I could only do it over here. I can't do it there. So I don't know what's wrong, but I can't fix it in the few minutes we've got left. So will you all say hi to get attendance? I'll worry about that tomorrow. I'll get that sorted out. We're almost finished, these guys. We've got a couple more to do on Wednesday, and then we can get started on, well, we only have 2 more sections to do after that. So make sure you say hi, because I only have 15 highs right now, which is not, oh, 16, which is not good, because there should be 20 of you. So, last chance. Yep, 16 it is then. So, oh, got a 17, good. It's only 3 missing then. Well, that's it. I'm going to hang around because I have some people who want me to go over some homework questions. So if you're interested, you could hang about as well, or you can just wait until I see you tomorrow. So bye-bye for those who are leaving right now, and hello, I guess, to those who are staying. Okay, I guess that's everybody who's staying. Okay, we'll start with you, Matthew. You get the first one, and then whoever else wants the next one until I've answered hopefully all your questions. So what's your next homework question, Matthew?
Question 9 on the volumes homework.
Okay. You got the information about it? Actually, I should be able to do that by just looking up myself. So if you can't find it, that's fine. I'll get it. But
oh, I have it right here.
okay.
Y is equal to 27x cubed. Y is equal to 0. X is equal to 1. And about x is equal to 2.
Okay. So let's put all that information together as a package, see what we get. Now you've got to be thinking disk method. So don't think shell method, because if you start letting that into your brain, you'll never get any of them right, because what you'll do is you'll make a monster method which uses a bit of one and a bit of the other, and neither work. So y = 27x cubed is pretty easy to do a sketch of, but you can check it on GeoBra. Y = 0 is the x-axis, and x = 1 is this one. So I now know that this is the region that we're going to rotate. And I also know that we're going to rotate it about the vertical line, x = 2. So far, so good. Did you have any problems with the construct, or was that the easy bit?
I think it was the radiuses part.
Okay, so when you are doing the disk method, the magic rectangle that you draw is in that direction. Do you notice it's perpendicular? Now this guy that we have involves us finding 2 radius. That's the small one, and this distance here, that's going to be the big one. And the formula that you use is the integral from C to D of pi, the big radius squared, subtract the small radius squared, dx or dy? That's not a trivial decision. Dx or dy?
dx.
Why? You're not sure?
Isn't it like dy when it's, or I don't know.
See, that's what's, you've got the shell method, you've got the disk method. Because those bloody methods are totally opposites of each other, you're probably thinking the shell method right now. And if it was the shell method right now, that would be a dx, right? But in this case, it's a dy. How do I know it? When you do the disk method, if the axis of rotation, that's where my pen is vertical, is dy. When the axis of rotation is horizontal, it's dx. So for the disk method, axis rotation vertical dy, axis of rotation horizontal dx. When it's the shell method, switch those two guys around. Right. Now, that gives me a clue. It tells me that this thing, and C and D all need to be in terms of y. So when I go to this picture, I'm going to say, oh, I need y equals 0 to wherever that is. So that means I need the number 27. So I'm going to go 0 to 27. Not 0 to 1, but 0 to 27. It's the y values. Stick out the pi. Right. I got a guy called the big radius, I'm going to square it. I've got a guy called the small radius, I'm going to square it. The small radius is the distance from the axis of rotation to the beginning of that rectangle. Now I know this dotted line is at position 2. I know this vertical line where the thing is at 1. So there to there, that's the small radius, and that distance is what number?
1.
Now, to get from here to here, which is called the big radius, what you got to imagine is, well, that total distance from there to there is 2. And this fella from here to here, right? He's going to be the second fella, right? He is going to be, right, that distance there. That distance there is x. This total thing here, isn't it 2 take away x? Except that guy isn't written in the way that I want it to be. I want it to be written as x. So it's going to be y over 27 cube root, which is 1/3 y to the third. So that x distance and that 2 distance, if you subtract them, that's this distance, right? The one we're calling the big. So this fella squared taken with that fella squared now gives us y to the 2/3 take away 1. And now it's just ugly power rule with fraction.
Wait, isn't it 2 minus 1/3 y to the 1/3?
2/3 minus 1/3 y. 2/3. Right. Where's the 1/3 y coming from? I'm not sure what you're thinking about here.
It's x is equal to
Oh, this
1/3.
here. Yes, you are right. Yes. and it's 2 take away 1/3 y.
Yeah.
Well cut. I went and said what it was, and then I forgot that that isn't the whole picture. So it's pi 0 to 27, 2 take away this guy squared minus 1. So that's actually makes it even worse, because now don't you have to FOIL this out, and you have an even uglier looking power rule with fractions all over the place. Well cut. Okay, someone else. Is your main issue here trying to get big and small radius, trying to find out who they are? Is that one of the
Yeah, and then
bottlenecks?
yeah, it's just really confusing. Like I don't know, just it's like a lot of stuff to keep track of. It's kind of hard for me.
It is. It is a lot for everybody. It is. It's like I got lost there, careless, but I did. So yeah, you have a lot of pieces that I have to keep track of. They all fit together. I mean, you put them together, it's like a puzzle, and the final answer will come out. But yeah, a lot of pieces to keep track of. Okay, somebody else who has a homework question, then, or maybe I'm finished. I don't know, whatever. Anybody got another question they would like, or just a general question? I can answer that too.
I have a question about number 12 from the same homework assignment.
Okay. Do you have the details handy? Save me having to go out and in.
Yes.
Okay, what you got?
It shows a graph and it says refer to the figure and find the volume generated by rotating the given region about the specified line. It has a
Okay,
region.
so I'll pause you that I really have to go in and do that one, because it looks to me like there's something visual going on, so you can't really see what you're doing if you don't see it. Okay, so let's find this fella. So it's question 12.
Yes.
Gotcha. And the view on it. Move over here, put a 12 on it. Oh yeah, I remember that one. Okay, so let me see if we can show you what's going on here. Right, it's this guy over here, right?
Yeah.
That's the picture. Now, refer to it. So I'm looking at that picture and I'm trying to find how to do R1. Right, refer to the figure in the volume and find the generate by rotating the given about the specified line. So the region they're talking about is that at least in this version, is that little triangle that's blue on the bottom, and it's being rotated about OA, but isn't that just another way of saying the x-axis? So I'm setting up only the bit of the picture that matters. So if you hold with me for a few seconds. I can now zoom back and let's fill in the missing details that we need so this question actually can be done. So that's basically the shape, rotated about the x-axis. Well, let's see what's missing. Well, isn't the equation of this line missing? Well, what do I know about this line? Well, it goes through the origin. Would you agree that it has a 4 by 1, so it's y equals 4x? Now, if I'm going to rotate about the x-axis, it means that my rectangle is going to be that fella. And this fella here is at position X. And let's start. It's the integral of pi from 0 to 1. Well, technically here I don't need a big takeaway or small because isn't it an x-axis and the bottom is 0? So don't I basically just need one radius? Now you may say, well, why do I only need one? Doesn't the bottom of this rectangle actually touch the axis of rotation? So that would be 0 would be the small one, so I don't really need it. And won't the big one be there? So it's pi, the integral from 0 to 1 of 4x squared. So you square that in power rule.
Okay, thank you.
Okay. We get any more questions? This is open to everyone or anyone.